Hi guys. Today I am going to go over your pretest that you took today. So let's see, a lot of the things that is on this test are some things that we've really been reviewing for the last couple of weeks. So I just want to see how well you guys are doing on this. So I'm going to work all the problems. Now if you don't understand a problem, you know you can always replay, rewind, watch it again. If you are having a problem on one of these problems that we're working and watching it on the video doesn't make it clear to you, call me, let me know. You have my number. So call me, text me, email me. Well, you'll get me faster if you call me or text me. So do that. I'm going to work the problems and then we will go from there, okay? And we'll have a test tomorrow and it'll be very similar to this. You're going to know exactly what you need to know by working the pretest. So here we go. Problem number 1. It takes Jennifer 20 minutes to walk to school. At what? Oh, guys, if you have not done this pretest, stop the tape, work these problems, because you need to know if you know how to do these or not. Okay, so be honest and work them, and then turn the tape back on and I'll go over each problem with you. Okay, all right. It takes Jennifer 20 minutes to walk to school. At what time should Jennifer start walking to school if she wants to arrive at 8:05 a.m.? Okay, so she wants to get here at 8:05. So that means we're going to have to back this time up to allow her time to, she wants to walk in the door at 8:05. So our T-chart, it's going to take her 20 minutes. So we need to find out what is 20 minutes before 8:05. What time should she leave the house? So I can look at this already and see 8:05. I can take 5 minutes away real easy. So I'm going to bank 5 minutes, and then that'll make this 8. Okay, so now if I banked 5 minutes over here, that leaves me 15 minutes. That's real easy to take away from 8 o'clock. So I'll bank that 15 minutes. I've done my 20. What time is it? 15 minutes before 8? 7:45. Okay, there's my answer. All right, it helps if you remember that the clock is real easy if you divide it into 4 pieces. And to go all the way around the clock is 1 hour or 60 minutes. So halfway around the clock would be 30. A quarter away around the clock is 15. That's why that 15 minutes was really easy. I know it's going to be 15 minutes until 8. Okay? All right. So try to picture how those minutes are divided on the clock. That helps you, will help you with those elapsed time problems. Okay? Number 2, Jennifer can walk 1 mile in 15. Jennifer's busy walking. Jennifer can walk 1 mile in 15 minutes. All right, Jennifer, 1 mile, 15 minutes. At that rate, how far can she walk in an hour? Well, I can make this a table real easy. That'll be how I solve this problem. If she walks 15 more minutes, she'll walk another mile. And if she walks 15 more minutes, she'll walk another mile. And if she walks 15 more minutes, she'll walk another mile. Every 15 minutes, she's walking a mile. Well, how many minutes are in an hour? Because we want to know how many miles she can walk in an hour. There's 60 minutes in an hour, so there's 15, 30, 45, 60 minutes. So how many miles is that? 1, 2, 3, 4. 4. don't forget your unit, miles. Okay? You might have done it another way, and that's just fine. Okay, as long as you get the correct answer, right? All right, number 3. Then bought 4 hamburgers for $1.89 each. The sales tax was 53 cents. What was the total price? Now, a lot of times we get that it's $1.89 for the hamburgers, and then you need to add the tax on. But the key is there's that little bitty word in there that they stuck in there, $1.89 each. So if you bought 4, we're going to have to multiply this $1.89 by 4 so that we get how much you paid for the hamburgers. So you've got 9 times 4 will be 36. 8 times 4 is 32, plus 3 will be 35. Our decimal, well, let's not put that in there. I want to show you how to do that the correct way here. And then you've got 4 times 1 is 4, plus 3 is 7. Now, so we've got $7.56. This is money, so don't forget your unit. You need to put the money unit. So you've got your dollars here. And because it's money, we know we go 2 places over to separate our whole dollars from our parts of dollars or coins over here, 56 cents. So $7.56. Now, that's the A part. What is our total price? Then, or is it? We have to pay sales tax. So now we have to add the sales tax on. Don't forget that. That's very tricky on this problem. So we've got 53 cents sales tax. So the total price is $8.09. So don't forget about if it tells you an item is for each item, you've got to figure out what that amount is. Then if there's sales tax, you've got to add the sales tax. Then you have the total of what you paid for it. Okay, now the B part says he paid with a $10 bill. What is his change? Well, if we have a $10 bill over here, actually I'm going to erase that. If I have a $10 bill and it was $8.09, what is my change going to be? So I'm going to have to do some borrowing up here from my zeros. So 0, 0, 0. I'm going to have to go over here and borrow from my tens. So that becomes 0. Then I borrow. Then I borrow. And I can start subtracting. 10 minus 9 is 1. 9 minus 0 is 9. My decimal comes straight down. When we're doing subtraction and addition, that decimal always has to line up. And then 9 minus 8 is 1. So the change that he gets is $1.91. All right, problem number 4. You're going to use this graph. It says use the information in the bar graph. How many students have dogs or cats as pets? So it can be either one. So I need to find out how many of each. Looks like there's 9 dogs and 8 cats. So 9 plus 8, 17. Don't forget your unit. Pets. Oh, students. Didn't want to know how many pets. You want to know how many students have dogs or cats. All right. Number 5. Tom bought a rectangular piece of land that was 3 miles long and 2 miles wide. The easiest way to work these problems, draw a picture. So here's this land. It's going to be a rectangle, 3 miles by 2 miles. And it says half of the land could be farmed. How many square miles could not be farmed? Okay, so half could be farmed, half can't be farmed. So the easiest thing to do is to figure out how much is this land. Well, if you've got 3 miles by 2 miles, to get the area, you're going to multiply the length times the width. So that would be 6 square miles is this total piece of land. And it wants to know how many square miles could not be farmed. So half could. This is not farmed. So what is half of 6 square miles? It would be 3 square miles. So you'd have 3 and 3. Okay, problem number 6. Which angle appears to be a 45-degree angle? Well, this would be where you're going to need to know what angles look like. What does a right angle look like? It looks like this. You can slide a piece of paper right in the edge of that and fill this completely out, the edge of a piece of paper. So this is going to be completely vertical. This is going to be completely horizontal. They intersect to form a right angle. How many degrees are in a right angle? 90. Okay, so we can get the angle of a line real easy, because if we just extend this line on out, this would be 90 degrees. So a line is 180 degrees. So this wants to know which angle would be a 45-degree angle. Well, we know it's going to be smaller than a right angle, and 45 is half of 90, so it would be right down the middle of this right angle. This would be 45 degrees. Is there an angle on there that looks like that? Angle A. Okay. Number 7. Round 5,555 to what? It wants to round it to the nearest 1,000. So, using the Cuba method, we circle the place value that we're rounding. We want to round to the nearest 1,000, so I circle it. I underline the number to the right of it. Circle, underline. And then, is it a big boy number, which is 5 or above? Or is it a little bitty baby number? It's a big boy number. So I'm going to round up. So this is the number I'm rounding up. So it's going to become 6. Once I round, I fill all the rest of these places in with 0. 1, 2, 3. So that 5,555 rounded to the nearest 1,000 is 6,000. All right, you guys should be pros at doing this. All right, number 8. The airplane weighs 20 tons. Uh-oh, I bet you're going to have to know how many pounds are in a ton. 20 tons is how many pounds? Well, how many pounds are in 1 ton? 2,000 pounds. So if 2,000 pounds are in 1 ton, how many are going to be in 20 tons? Now, guys, remember the hangy outie? This problem is really easy. Look how many zeros. If you have a 0 on the ends of the numbers, you can just take them and put them down here. So how many do I have? 1, 2, 3, 4. There are 4 zeros above my equal sign here, and they're all on the end, so I can just bring them all down here. 1, 2, 3, 4. And all that leaves me with is 2 times 2. 40,000 turtles? No, pounds. So if it's a 20-ton plane, does it say? Yeah. If an airplane weighs 20 tons, that's 40,000 pounds. Okay? 2,000 pounds in 1 ton. That's what you need to remember. All right. The next one, number 9. 1/3 of the 18 flowers are roses. How many flowers are roses? All right, well, we know we've got 18 flowers. We're going to need to divide them out. How many piles do we have? It tells us right here. When it said 1/3, it tells us right there. 18 divided by 3. 6. Roses. Okay? Or flowers. It doesn't matter. I don't care if you put flowers or roses on that. That's either one will do. All right. Problem number 10. Write 625 thousandths as a decimal number. Okay, so now we know that decimal numbers, we just reviewed this yesterday. Was it yesterday? I think so. Is the third place value over here to the right of the decimal. And I have 3 numbers, so I think it's going to fit in there. Lovely. Yep. So there it is as a fraction, and there it is as a decimal number. Okay. The next problem, number 11. Write 123 thousandths as a fraction. So here's the decimal number. So we would write the number 123, and then the place value is our denominator, 1/1000ths. You will know that you have written the problem correctly if you're writing a fraction to a decimal or decimal to a fraction, you will know if you have it correct if when you say it, it sounds the same. You shouldn't read it differently. If it reads differently, you have it incorrect. You shouldn't be able to tell by saying it whether you've written a decimal number or a fraction. So that's one way you can check yourself if you've written it right. Okay. Number 12. We've got $47.36. And we are going to add that. Make sure that you are careful with your mathematical operations. A lot of you subtract when it says add, and you're adding when it has a subtraction sign. So be careful. That means you need to slow down. You get no points for finishing quickly. All your points come from being careful. So slow down. $47.36 plus $9.86. All right, so what do we have here? We have 6 plus 6 is 12. 8 plus 3 is 11, plus 1 is 12. 9 and 1 are 10. I'll add those because that's easy. Plus 7, 17. Our decimal comes straight down. And 4 plus 1 is 5. So the answer to that is $57.22. Easy peasy. That should all be easy for you guys. Number 13. We have decimal numbers that we're adding. Now the trick with adding decimal numbers, remember you've got to keep those decimals lined up. It changes the whole number if you don't. So we've got 31.428. Oh, did you guys grab your ears when I said that? Did it hurt your ears? I hope it did, because you don't say point. 31 and 428 thousandths. All right? Okay. Plus 17 and 680 thousandths. What are we going to get? A big number. Let's see. 8 plus 0 is 8. 8 plus 2 is 10. 6 plus 4 is 10, plus 1 is 11. Bring that decimal down. 7, 8, 9. 3 plus 1 is 4. So our answer is 49 and 108 thousandths. Okay. Number 14. 487 times 7. 7 times 7, 49. 8 times 7 is 56, plus 4, 60. 7 times 4, 28, plus 6, 34. 3,409. Again, if you don't get these answers and I'm going too quickly, stop the video, look at your answer, and rewind it. Look to see how I did it. These should not be difficult for you. You guys know how to add and subtract, and you guys all made A's on your multiplication tests all the way up through your 9. So you should be rocking and rolling. Number 15, we've got 100 times 27. Now, 2 zeros on the end, the old hanging outy method. 1, 2. We can just bring those right down. And that leaves us with a really easy multiplication problem. 1 times 27. 27. So our answer, 2,700. Number 16. We've got $6.37 divided by 7. All right, so we're going to start out putting our money value in there so we don't forget. Because you have to have that. This decimal comes straight up and our dollar sign goes straight up. All right, so can we get anything 6 divided by 7? Can you divide 6 7 ways? No. So there we go, is a 0. So then, well, if we put 6 with the 3, what about 63? 63 divided by 7? Yes, 9. Remember, dead monkeys smell bad. We've divided. 63 divided by 7 is 9. You have to prove it. What is it then? If you say yes you can, then what is it? Multiply it. 9 times 7 is 63. Then we subtract. 63 minus 63 is 0. And then if there are any numbers left in our dividend, we have to bring them down. 7. Now we start all over. 7 divided by 7, yes, 1. Prove it. What is 1 times 7? 7. Subtract 7 minus 7. And bring down. There's nothing left to bring down. I have no remainder to bring up here, so I am through. My answer is 91 cents. Okay. Number 17. There's several things that we have to put into place here. This is going to be a multi-step problem. We're going to have to apply the order of operations. So what is the order of operations? Parentheses first, then exponents and square roots, then multiplication and division, then addition, subtraction. Any mathematician, no matter where you go in the world, will work the problem the exact same way. And that's why we have that rule, so that we all understand how to do numbers and work numbers. It's a unified thing that we do, okay? It's like time. We all tell time the same way. 3 o'clock is 3 o'clock. Okay? All right. So, the first thing we're going to do is parentheses. What is 12 divided by 4? What can I multiply by 4 to get 12? 3. So then my problem becomes 2100 divided by 3. So I'm going to have to work that down here. 2100 divided by 3. 2 divided by 3, I can't do that. I can do 21 divided by 3. That's a 7. Now I put that 7 right over the 1 in 21. Remember, keep your place value. Very, very important. So I've divided. Now I have to prove it. What is 7 times 3? 21. Subtract. 21 minus 21, 0. Am I through? There's zeros. No, I'm not through, because I still have to bring down. Are there any other numbers here that I haven't divided by 3? Yeah, there's 2. But now when you bring down, you can only bring one number down. Can't bring, there's 2 numbers left. But you can only bring one number down at a time. So I'm going to bring down that 0. Now I start all over again. 0 divided by 3 is what? What can I multiply 3 by to get 0? 0. Prove it. What is 0 times 3? 0. Subtract. 0 minus 0 is 0. Are there any other numbers that I haven't used? Yes. This 0. Bring that 0 down. All right. What is 0 divided by 3? 0. Prove it. What is 0 times 3? 0. Subtract. 0 minus 0. 0. And bring down. Or do I have any other numbers left in my dividend? I do not. Now I'm through. I have no remainder down here, so I don't have anything to write up here. My answer is 700. Okay? Very important that you don't forget. Even if there's zeros, you still have to bring them down. Okay. Next problem. 7c equals 420. Now remember, when you have a number with a letter snugged up right next to it, that means multiply it. Remember the reason? Because if we had 7 times c, we wouldn't know. Well, is that 7xc or is that 7 times c, or what is that? So it's been agreed in mathematics that when you have a number and a letter, we just assume that that is multiplied, and we just take the x out of it, so it's not confusing. So what can we multiply by 7 to get 420? Division problem. Undo multiplication with division. So let's work that. 4 divided by 7, can't do it. 42 divided by 7, I can do that. 6. Prove it. What is 6 times 7? 42. 42 minus 42, 0. Am I through? No. There's still another number in my dividend that I haven't divided by 7. So I have to bring that down. 0 divided by 7, 0. Prove it. 0 times 7 is 0. Subtract, bring down. Now I'm through, and my answer is 60, not 6. 6 times 7 is 42. 60 times 7 is 420. That's why it's very important. You need to get those zeros on the end, and that's how you do it, by keep bringing down, okay? All right. 19, we've got 614 in 17, 25, 110. Remember, very important to keep your place value together. And we need to know what n is. Well, first, before we figure out what n is, I need to figure out, well, what do I need to add to all these numbers to get 200? I have to figure out what they all add up to. So 6 plus 4 is 10, plus 7, 17, plus 5 is 22. So I've got 22. So carry my 2, 2, 3, 4, 5, 6, 7. And then I have 100. So those numbers added together are 172. Now, that's not my answer. That's what these numbers added together are. I'm trying to figure out what is n. Because if you put, a lot of you will stop right there and you'll say, oh, n equals 172. Well, if that is true, then I could put what that means. I can replace n. You says n equals 172. I should be able to put that answer, and there's no way I'm going to get 200. So that's not the answer. That tells me what I need to get to 200. So now I can take 200, I can subtract out all these other numbers, get rid of them, and I find out that n is 28. Okay? Be careful on that. A lot of you you do a really good job starting the problem, but then you don't finish it. Okay? And the trick to that is how you'll check your work. If you say that the n or x or d or whatever it is equals a number, go put your answer in the problem. Does that solve the problem? That's how you can check and make sure you have the right answer. All right, number 20. 23 times 50. I'm going to do the hangy outy. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11, and that's 1,150. Okay? So, all of those problems should be, they're problems that we have been doing now for months. Some of the little problems that might give you a little bit of a problem, you need to remember about your degrees. There's 60 degrees in a circle. There's 90 degrees in a right angle. If you remember those things, those are the type of things that are going to help you solve some of these problems. If an angle is less than 90 degrees, it's a cute little angle. And if it's greater than 90 degrees, it's an obtuse angle, right? Okay. You need to know how many pounds are in a ton. You're probably going to need to know how many ounces are in a cup. How many ounces are in a cup? We just did that yesterday. 8. 8 ounces in a cup. How many cups in a pint? 2. Remember, each prince and princess had 2 crowns. Okay. There was a prince and a princess for each queen. How many queens were there? 4. So if you can draw that land of gallon, and they ask you a question and they say, oh, how many quarts in a gallon? If you're going, oh, I can draw it on your paper. I would love to see a big G with your Q's and P's and C's and all that written on there. It would thrill me. I sometimes will still do that. Sometimes it's just easy to get confused, especially if they're wanting you to do 2 or 3 different things to it. So write it down. Use your paper, okay? All right, so I am going to leave it to you. We'll talk more about it, I guess, at our class meeting on Friday, which will be tomorrow. So I know you guys are going to rock it. You've done really well. You've done really well getting your homework in, and From the comments that I've gotten, you haven't missed very many at all. A lot of you said you had 100% on your homework, and that makes me so happy. So, all right, I want you to show what you know.